Bismillahirrahmanirrahim. My name is Vijahat Rashid and my group members are Saifullah and Subhan Iftihar. Before proceeding towards the hardware of our project, Battery Management System, I would like to explain the basic idea of our project. Basically, this project will monitor the battery pack of an electric vehicle and send its real-time data to cloud database from where it can be accessible wirelessly. And in the case of any fault occurrence like increasing temperature or current of the cell, it will generate an alert for the further action. We have divided our project into two parts. One is the user terminal and the other is a manufacturer terminal. By using IoT, we try to engage the manufacturer with the user by sending the different parameters of the cell to cloud database from where it is accessible to both the manufacturer and the user. Now let's move towards the hardware portion of our project, which is approximately more than 75% done. Here we are using 4 lithium-ion cells as a battery of an electric vehicle to monitor. We have connected all these 4 cells in series in order to get the constant current across the load. We are using these 4 variable resistors to set the voltage point of each cell and using this thermistor as a temperature sensor for sensing the temperatures of the cell. For charging the cell, we are using the step-down transformer whose input is 220 volt AC and output is 12 volt AC, which is then converted to DC by using the rectifier. As we are taking the 24 volts as an output from the transformer, so after rectification we had to step down it to 19 volt approximately in order to charge the 16 volt battery. So we are using buck converter here to convert the 24 volt DC to 19 volt DC and then supplied it to cell using relay for controlled connection and disconnection of the charging according to our need. As we have 16 volt terminal voltage, so when the terminal voltage will fall below the 15 volt, the charger will be connected. This is also a buck converter which takes 19 volt from the buck converter and step down it to 5 volt for circuit operation. Now we are using ESP32 to gather all the parameters of the battery and send it to Firebase database, which is a cloud platform. In the parallel, it is displaying this data to LCD. For testing, to change the temperature, I will use the soldering iron. So when I brought the soldering iron closer to the thermistor, it senses the increasing temperature and changes the temperature value, which can be seen through this LCD. And now as we are sending this data to the cloud database, so the temperature value also changes in the Firebase database, and we are retrieving this real-time data from Firebase using our application, so the temperature value also changes in our application also, which can be clearly seen through our application. So when the temperature goes above the 110 degree Fahrenheit, then the buzzer will make a beep sound as an alert for the high temperature. Now moving towards the voltage monitoring of the cells and turning on the bulb which we are using as our load. When I turn on the load, the terminal voltage start dropping, and which can be clearly seen through this LCD. As it is also connected to ESP32 and sending its data to Firebase database, so the real-time changing values can be also seen through this Firebase and our application. So these are the 4 real-time values of our 4 cells.